Yes.
Okay. So today we will start pandas. Okay, we have covered NumPy. Now we are starting pandas. So pandas is basically for data wrangling and data manipulation. Okay, it has two things. One is series and data frames. So let's import the libraries first. Import NumPy as NP. Import pandas as PT. So we'll execute this. Okay, so first we'll start ahead with series. Okay, so what is series? Series is basically a one-dimensional array, labeled one-dimensional array. Labeled means these values will have level, the row levels, and it like list. I mean, it can also hold any object type, I mean, any data type in Python. But the thing to remember is at a time and when you are defining in a single series, I mean, it must contain all the elements of the same type. Okay, if it is different type, it won't accept. So that's the difference between list and series. But in list, in a single list, it can contain multiple data types. But in series or data frame, in series, it can contain only the same data type. Okay, so let's define it. Obj equal to pd dot series 6 comma 10 minus 9 or 3. These are the values. See, if I go into print it, as I mentioned, these are labeled, right? So these labels will come automatically. And as you all know, that Python index starts from 0. So 0, 1, 2, 3. So 0 index value is 6, 1 index value is 10, 2 index value is minus 9, and 3 index value is 3, right? So this is the labeled one-dimensional array. And the data type is int64. If I want to print second value, like obj1 index, 1 index means second value. So let's see, 10, right? Similarly, I could put 0, 1, 2, 3. So say 2, 2 means 0, 1, 2, so it will print minus 9. So now to remember like how to get the values of the series, the command is obj dot values. It will show us all the values without the levels. Okay, so obj dot values. If I print it, it's an array, single dimensional array, 6, 10, minus 9, and 3. And obj dot index, it gives us the index. Okay, so obj dot index, it will give us the index, and since the index is the default index like 0 to 3, so it's a range actually. So 0 to 4 range and step equal to 1, right? So that's how Python will output the index. And if it is different index, then we'll like say A, B, C, D. I'll show you. We can change the index also. Now say we are going to change the index. So this index can be changed. Okay. How to change the index? Suppose I'm defining obj2 object2 equal to pd dot series, the same values 6, 10, minus 9, 3. And here we are specifying that index equal to, okay, D, B, A, C. So these will be the new index in place of 0, 1, 2, 3. Let's see how it comes. See, earlier it was 0, 1, 2, 3. Now we have changed the indexes to D, B, A, C. So 0 has been replaced by D, 1 has been replaced by B, 2 has been replaced by A, and 3 has been replaced by C, because we have defined like that. Okay. Now, if you print again obj2 dot values, the values will be same because we have used same values. And obj2 dot index. So what will be the index here? Who can say? What it will be printing? Obj2 dot index. Hello, can anyone chat or speak?
DBAC.
Yeah, right. So obj2 dot index will be dbac, and d type equal to object. Okay. Earlier d type was integer 64. So now if I want to access with new index, I can do that like obj2 and then quotation B, I mean single quote B or double quote B. So obj2 quotation B will give me value of 10,
10, 10.
right? And obj2 of D, what will come here?
6.
Yeah, got it right. So having said that, okay, now suppose I'm okay. Now say let me change the index d. Okay, I mean value d. So this 10. So we get 2 of d equal to 11. Okay. Now if I print the obj2, what will happen? I mean, 10 will be replaced by 11, right? I mean, sorry, not 10. The first value d was 6. So 6 will be replaced by 11, right? Got it? Now let's say I want to access a specific indexes value at the specific indices. How can I do that? Obj2, then third bracket. This list we are defining when we are having more than one index. So earlier we used just single quote d, right? But whenever I have more than one index to access to, that time you need to define inside list. Remember this, okay? Whenever we have more than one index to access the values from, then you need to use list, and you need to mention all the indexes inside a list. That's how it works. So obj2, then third bracket, then inside a list, these are the indexes that I want to access to. So what will be the value? So it will give me values for C, A, and D. C, A, and D. So 3 minus 9 and 11. D is here. That's why. Okay. Got it? Clear? You can type in chat box. Is
Yes.
it clear? Okay. Now say obj2 greater than 0. What I want to do is I want to uh, access elements from obj2 where elements are greater than 0. Okay. So let's see. So here only one negative value was there, which was less than 6. But I have all the positive values like 11, 10, 3. So 11, 10, 3 will come, right? Got it? Now if I would have put say less than 3, what would have come? Minus 9, right? Minus 9. Now let's say I want to multiply by 2 with all the elements. Yeah. So obj2 star 2, it is multiplying like 11 into 2, 10 into 2, minus 9 into 2, 3 into 2, right? Similarly, these are some of the operations. It is arithmetic operations. Now, similarly, if I do say np dot exponential, np dot exponential means exponential. So it is the power object 2 if I want to calculate. So np dot exp of object 2. So it will calculate the exponential of all these values. It is about 11, 10, those things, right? Okay. Now let's say I want to see whether a specific index is present in the data type. I mean, sorry, not data type, in the object. So obj2 is our object, new object. So B inside quotation, because this is character, right? That's why inside quotation. B in obj2, this will come up with Boolean values, either true or false. Okay, so B in object 2. So you will check whether B is there in object 2. So B is there in object 2. Yes. This is the no. This is the original series. So B is there. Yes. So it will give me a true value. Okay. E in object 2, what it will give? Any guess?
False.
Yeah, right.
False.
Because E is not there. E in object 2, E is not there. That's why it's giving false. Okay. Now let's say we want to create a dictionary. Sorry, you want to create a series from a dictionary. You know dictionary, right? Key value pair. This is one key value pair. This is second key value pair. This is third key value pair. This is fourth key value pair. Okay. Suppose I have say value for Ohio is 35,000, value for Texas is 71,000, Oregon 16,000, Utah 5,000, and we have mentioned like age data inside this dictionary, and then we are using this formula to convert to series. PD dot series. This is the formula to convert this object to series. PD dot series of S data, and I am storing in object 3. So object 3 values will be, so whatever keys are there, remember those will be the labels, and these values will be values. So these will be labels and this will be values. So let's see obj3. So Ohio, Texas, Oregon, Utah are the levels or say index row indexes, and these are the values. D type equal to int 64. Now say I want to access the value at Oregon. So obj3, then inside bracket, third bracket, quotation Oregon, because these are characters or strings, right? So let's see what value will come. 16,000, right? It should come 16,000. Now, now we can override the indices also. Okay, so how can I do that? Say we are defining the states as states equal to California, Ohio, Oregon, and Texas. Then I'm going to create a new object 4. Object 4 equal to pd.series s data, index equal to states. S data means this s data, earlier s data, and index equal to states. So whatever I have defined in states, those will be considered as index. Now remember, California was not there earlier, right? Ohio, Oregon, Texas were there. So what will happen is it will create the indexes, but the value for California will be null because earlier California was not there. So let's see what will be the object for. See, California null value because we have not provided any value for California, right? We have just changed overridden the indices. That's why indices will get overridden. California, Ohio, Oregon, Texas. But value for California will be null because no value was provided. And this value, you know already it was there in S data. So it will come from S data itself. Ohio 35,000, Oregon 60,000, Texas 71,000 if you remember. Yeah. So yeah, that's the thing. And now say if we want to check some null values or missing values, the formula is pd dot is null or object 4 dot is null. Both will work. So let's see first this comment. Pd dot is null, obj4. Is there any null value in object 4? So for all the levels, it will show us whether it is a true or false. True means yes, null value. False means no, value is present. Some value is present. So California true, others are false, 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 right? And data type will be Boolean. Same code could have been scripted. And we could script this way also. Obj4 dot is null because obj4 is already a series, right? That's why automatically it's taking these functions are for series and data frames. So obj4 dot is null will work similar to this. So let's see the output. California true, Ohio, Oregon, and Texas false. Okay. Now similar to is null, I have another function not null. I'll check now whether it is null value. I mean, is it not null or null, right? So what it will give, it will give the value opposite to this. Not null, so this is false, and these are not null. Yes, true, true, true. So let's see. Okay, so false, true, true, true. Not null because this is null, right? So if I put not null, then it will the condition is false. Okay. So the same script pd.notNull of object 4 could be scripted as like obj4 dot not null. This will give the same output. California false and the others are true. Now, suppose we want to add two series obj3 plus obj4. Obj4 was the series where California was not there, and obj4 obj3 California was not there, and obj4 California is there. So if I put obj3 plus obj4, and obj3 also had another state, I don't remember right now. Yeah, so Ohio, Texas, Oregon, Utah, right? So let's do object 3 plus object 4. Basically, how it does is California was not there in object 3, but it's there in object 4. So null value plus null value is null. Okay. Ohio 35,000 plus 35,000 is 70,000. Okay. Oregon 16,000 plus 16,000, 32,000. Texas is 71,000 plus 71,000, 1,42,000. And remember, Utah is the index which was present in obj3. It had some values also, but this value, this index is not there in obj4. So what will happen is in Python, value plus null is a null value. So value from obj3 plus value from, I mean, here the uta is not present, so it will be null value, right? So what it will do is it will calculate all the values for all the indexes present in both obj3 and obj4. Okay, got it? Clear? Okay, so now, like say we want to name this series, entire series as a name. So how can you do that? obj4 dot name equal to population. So this entire series I can name it actually. Entire series, let me give a name as population. I'll show you the output. And I want to give the index column a name. Index column, only the index column a name. So how to give that? obj4 dot index dot name equal to states. Suppose I'm giving a name states of this index column, and I'm giving the name of population for the entire series or say data. Okay. obj4 dot name equal to population, obj4 dot index dot name equal to states. Now let's print it. See, states have been added as a column name for index column, and this series, entire series, have been named as population. Okay, data type equal to float 64. But okay, so you know the object is this one we defined earlier. Okay. Now let's say we want to change the indexes. You already know how to change it, right? So obj.index equal to, I'll change it directly here. What we'll put is obj.index equal to Bob, Steve, Zeph, and Ryan. So this zero value will be replaced by Bob, one value will be replaced by Steve, two value will be replaced by Zeph, three value will be replaced by Ryan. So obj, you can see it, Bob 6, Steve 10, Ryan minus 9, sorry, Zeph minus 9, and Ryan 3. Now, if I want to access the value for Bob, you know already obj and then quotation Bob 6, right? Similarly, say Steve, value is 10, right? Okay, so that's about series. Hope it's clear to all of you. Okay, so now you'll move forward with pandas. Okay, data frame. So data frame is a like m cross n data set. M is number of rows and n is number of columns, right? And pandas data frame is the important aspect for data science and machine learning, because this pandas data frame we are going to use for our data sets in to analyze statistically or to analyze with data science, right? Let's understand that. Okay. So basically, initially say let's have some dictionary. So data equal to remember this is key value pair, first key value pair, where key is state, but value is not a single value. Value is a list. Okay, entire list. Remember, because this is the, sorry, this is the list, right? And it has one, two, three, four, five, six elements. So state is a single key and it has 6 elements as the value, key value pair, right? Then again, this is second key value pair. So here is the key, and 2000, 2001, 2002, 2000, 2001, 2002, these are elements as the values for this second key. And this is the third key, and the values are 1.5, 1.7, and so on. So this is the complete dictionary now, you know, right? Because it has 3 key value pairs, and we are storing it in data equal to. Now we are going to convert as a pandas data frame. So what's the code? pd dot data frame, like pd dot series we used for creating series. pd dot data frame we used to create a data frame. So df equal to pd dot data frame of data. Let's say df printed, how it will look like. So the key, these will be the columns. Key values will be the columns, and these values will be for the respective columns. So state like Ohio, Nevada, 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 right? Year 2000, this is the year, and population is 1.5, 1.7, 3.6, 2.4, 2.9, 3.2. So this is a structure now. This is called pandas data frame. It will have again levels. Okay, by default levels is 0 to that range, I mean maximum range, number of observations, but you can change it. Like series, you can change the index also if required. Okay, now for this data, remember some of the functions like I explained to you earlier also. Like so, df dot shape is going to give me, like when I explained in terms of array, right? So this works like for data frame also. Df dot shape is like number of rows and number of columns. So here six rows and three columns, so six cross three. And if I want to check the number of rows specifically, so that will like length. So length means the length of the data frame. Length is 6 here. So number of rows. Okay, if I want to check the number of columns, length df dot columns. Df dot column means only the columns and then putting length. So length of df dot columns will give me the column number. So three, right? And if I want to see only the columns from the data frame, so the command is df dot columns. Okay. Now you can ask me why do I need to use df dot columns, because I can already see the data. I mean, you can ask as a layman, no harm. Then I'll say, okay, suppose you have 500 columns of a data set, and you are going to analyze that. So can you visualize the 500 columns? No, right? That time this syntax will be important. Like if you put df dot columns, you can see all the 500 columns at a place. So it's important. I mean, you can understand like what are the columns present, right? That's why df dot columns is important to check the columns of the data frame. And how to get all the elements, number of elements for the data frame. So df dot size. Okay, df dot size will give you the total number of elements, which is nothing but 6 cross 3 also row number, I mean row number and column number. Okay, you can calculate here also. I mean, count 1 2 3 4 5 6 7 8 9 10 11 12 and so on. So 18 will be there. So df dot size, and as you know, like dimension, like 1D array or 2D array or something like that. What is the dimension? Obviously this will be 2 because this is a 2D array. I mean it is like 2D array, so dimension will be 2. Now in statistics or data science, if I load some data, basically we prefer to, after loading data or after uploading data, we prefer to have some random views of the data, or say we want to check what is there in data. And that's why we sometimes, many times, we want to see some of the records, like the first 5 records or say last 5 records, those things. So df dot head will give me first 5 rows. So let's see what is there in first 5 rows. Suppose I can't load the complete data, but I would like to see some of the records. So you can use df dot head. It will give the first 5 rows. And from the first 5 rows, you can see the column names as well as the respective values. So you can also understand that, okay, this is a categorical column, this is an integer column, and this is a float column, right? Got it? And df dot tail will give you the last 5 rows. So similar, like df dot head, df dot tail gives the last 5 rows from the data set. So by this approach, you can see like what are the first 5 rows of the data set, what are the last 5 rows of the data set. So you have a good understanding of the data as well as the respective values of the columns, right? Now say we want to show first 3 rows, not the default. So by default, df dot head will show first 5 records only, and by default, df dot tail will show the last 5 records only. Now, if I want to see the customized number of rows, like say 3 rows, df dot head 3. Okay, if you put 3, then it will show the first 3 records. Similarly, if you want to show the last 3 records, df dot tail 3. If you put 10 here, it will give the first 10 records, first 10 rows. Okay, and this will be giving say first last 10 rows or 10 observations, right? Got it? Clear? Okay, so now suppose I want to see the row names, right? Like series, similar thing will work for df also, df dot index. If I put here the default index is 0 to 6, right? Because number of observations. So it will show like that only, range index 0 to 6 and step equal to 1. How to see the column names? df.columns will give you the column names as I already have shown you, right? And suppose I want to see the values. So df.values will show me all the values like here 2001, only the values. See here, no index is coming, right? Because we want to see the values only. Sometimes it could be important if you have small data, like if you want to have a quick glimpse of the values, all the values, how it is parsed, or how, what are the different columns talking about. That time it is important. And and how to check the data types of the individual columns. Df.dtypes will give you the data type of individual columns. So let's check df.dtypes. So state is an object. Object means like because it's a categorical column, right? It won't be showing like int, float, etc. It will be an object. And here int 64 integer, pop float 64 float value. Okay. So now you know how to see the first 5 rows, how to see the last 5 rows, how to see customized number of rows, how to see customized number of last few rows, how to check the column names, how to check the values, how to check the data types. Now, suppose you want to have an overall description of the data. That code is df.info. So overall description of the data. So df.info. If you and remember, you need to give cross bracket. Okay, df.info. What it shows is it shows a lot of things like class pandas.core data frame. So it will first object class it will show. Then it will show the range index, like what are the ranges, 6 entries 0 to 5, right? Then it will show data columns, total 3 columns. Then it will show the respective data. I mean, just to have a view, like say index number is 0 and 2, column equal to state year, pop, non-null values. Okay, non-null values like 6 non-null values and count. Okay, it will give the count and non-null and dtype object in 64 and float 64, right? Got it. And memory usage also it will show like how much memory it has consumed. Okay, 272 plus bytes. So if you put df.info, it will give this information. Okay. Now, after we have checked the info, it's important to have an overall view of the data, like how many rows are there, how many columns are there, what are the non-null values, what are the dtypes together. I mean, without using individual functions like index, values, and columns, etc., right? And the dtypes. So the four, so these four dtype, values, columns, and index is coming at a single place. If we put df.info, right? Now, suppose I want to have a statistical summary of the data that we are using here. So that formula is df.describe. What it will give is it will show different statistical measurements. So don't get afraid and don't be afraid. I'll cover a statistics class also, that time you'll understand what is mean, median, mode, those things. And in case it you know, yeah, it's good actually. So if I put df.describe, it will show the count for respective numeric columns. Okay. So count 6, mean, average, mean means average, 2001 to this one 2.55. Standard deviation. Standard deviation is a measure of dispersion or variance actually. So standard deviation is nothing but square root of variance. I'll explain these things. So 0.89, 0.83. As of now, remember that these are some of the statistical measurements. What is the minimum value of this column? 2000, and this column is 1.5. This is 25% percentile value. Okay, 50% percentile value, 75%, 75th percentile value. So 25th percentile value means less than or equal to this value, there will be 25% of the observations. 50% percentile means less than this value, there will be 50% observations for year column. 75th percentile means 75th percentile means uh, less than this value, there will be 75% of the observations. Okay, that's what it talks about. So this is Q1, quartile 1, this is quartile 2, this is quartile 3. Okay, this is the maximum. Okay, so you get some of the statistical measures for all the respective numeric columns. Okay, and there is one more function df.core. It gives the correlation matrix. I'll explain in detail when I'm going through statistics class. But as of now, remember that correlation gives me some measurement by which we understand whether two variables are linearly related or not. It does not measure nonlinear relationship. Be careful. It measures only linear relationship. If the relationship is linear, then only it measures like that. So year versus year correlation will be always one. So variable, say if I put single variable year versus one, it will be always one. So pop versus pop is also one. Okay. So year versus pop correlation is 0.77. Okay. Generally, correlation value will lie from 0 to 1. So if it is close to 1, then it's good. It has positive correlation. If it has less than, I mean, if it is equal, I mean, if it is equal to -1, it is having a strong negative correlation. If it is having something like say minus 0.77, then also very negative correlation. Okay. So year versus pop correlation and year pop versus year correlation will be same because this is nothing but between the both. So if you interchange the position, it does not matter. The correlation value will be same because variables are same, right? Okay, so now we have basic understanding. I'll explain in detail what is correlation. Now let's say we want to call the data which we printed earlier. So pop state year. Okay, now say so here like columns are not supposed in order. Suppose we want to have some order, okay, as per our own customization or definition. So how to do that? PD dot data frame data, this data columns equal to state year and pop. I want first state to come and then year to come and then population to come because I want to see state wise and year wise population. Okay, population for every year for all the states. Okay, if I want to show like that, so this will be the command. So let's see. Period dot data frame data columns equal to state year pop. How it is coming state year and pop. Okay, if you would have if you would have put here year state and population, it would have been like population for each state for each year. Population for each state for each year. Okay. Here there are two states, Ohio and Nevada. So Ohio 2000, 2001 to 2002. This one. So let me change back. Okay. Now say you want to pass the column names. I mean, you want to change the column names as well as the index names, right? So how to do that? df2 equal to pd dot data frame. This data, the same old data we are using, which we defined earlier, columns equal to. We can put columns equal to. This will change the column names. Okay. State, year, pop, and depth. Okay. Remember this column. Suppose we are going to create a new column. So directly we are mentioning here. Okay. This is the beauty of Python. So columns equal to state, year, pop, and then we are defining a new column depth. Okay. And index equal to 1, 2, 3, 4, 5, 6. Okay. We are using 1, 2, 3, 4, 5, 6. So let's see how it runs. So df2 we are printing. Okay. So state, year, pop was there already. Depth column came, but obviously since we did not pass any values for the depth column, the values will be null. Got it? And check the indexes. Earlier it was 0, 1, 2, 3, 4, 5, but now we have used 1, 2, 3, 4, 5, 6 as strings. So this has been replaced 1, 2, 3, 4, 5, 6. Okay. Now if you want to check the column names, df2 dot columns, it will show state, year, pop, and depth. Right? State, year, pop, and depth. Right? D type equal to object. And if I want to check the row names or indices, df2 dot index, you know already 1, 2, 3, 4, 5, 6. D type equal to object. Now suppose I want to select a specific column. Okay, so what I need to do is df2 of this state. I mean state. You need to pass the parameter as a string. Okay, so df2 you pass state, so it will fetch the state column. What is the state column? State column was Ohio, 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 Nevada, Nevada, Nevada. The respective index will also be shown so that it gives you the flavor like how it is structured. Okay, like this. If you want to put inside the quotation, you can call like this inside third bracket. But if there is no space in a column name, remember, if there is a no space in column name, you can use this code also, df2 dot state, without using third bracket, without using quotation, directly you can call it. But if we have a space in column name, that time we will use this column, this code, I mean, inside quotation, because that time it won't work. It will give a, suppose I am say state of US kind of, so it will give an error, right? Obviously, because like this. But if I put inside this column is not there, but if it would have been, then I should have put like this, then it would have worked. Okay, got the difference. So let's see df dot 2, I mean df2 dot state, it will give the same output because the syntaxes work same, only the way we write, I mean, the way we write is different. Okay, similarly if you want to print year, df2 dot year. Okay, okay, so df2 you have this already. Now let's say I want to change some. Okay, I'll show you how to change the values of depth column. Now let's say I want to access some specific index. Okay, so remember if I have so remember this, there are two functions, lock and ilock, which is important. Lock function we will use when we have uh, we don't have the default indexes, but instead we have some non-numeric index. That time we'll use lock. So df2 dot lock and then 6. This will give me the sixth row. I mean this row, df2 dot lock. Then if I put 6 inside quotation, I mean the respective index, then it will give me the values for all the specific record. Okay, state Nevada, year 2002, population is 3.2, and date is null. See, this particular record came Nevada 2002, 3.2, and null, right, for 6. Suppose I want to, okay, now what I'm going to do is I'm going to assign some values for date column. So how to assign that? df2 date equal to 1.67 and then printing df2. So what it will do is it will assign 1.6 values for all the rows for depth column. 1.67, 1.67, 1.67, 1.67, right? Got it? Now, without assigning some value, suppose I want to give some range of values to depth column. Okay, so that time what we can do is df2 date equal to np.arrange. You know, np.arrange will give me 0 to 6. 6 dot means float value. So 0 to 6. Any number between 0 to 6. Okay, so those values will be assigned to depth column. Let's see how it is assigned. 0, 1, 2, 3, 4, 5. Okay, as I have mentioned already, it has been 6, but it takes values from 0 to 5. 6 will be excluded because closed bracket and open bracket. Okay, so you know how to assign values for depth column. Okay, now say another way of assigning some values to a particular column could be, say, value 1 equal to pd dot series. Okay, this is the values, index equal to, okay, 2, 4, 5, 6. Okay, suppose you are assigning index equal to 2, 4, 5, 6 for these values. Then I'll put df2 date equal to val. So this val will come. So what will happen is, interestingly, the respective index like 2 will be replaced. Value at index 02 will be replaced by minus 1.2. Value at index 4 will be replaced by uh, minus 1.5. Okay, and value at 5 will be replaced by minus 1.7. This one, and value at 6 index will be replaced by minus 1.9. So this value will be minus 1.9, right? So let's see. Okay, see, value at 2 has been replaced by minus 1.2. This is one minus 1.5. This is minus 1.7. This is minus 1.9. And since we have clearly defined the values here, and we have not defined values for other indexes. So like 1 and 3. So 1 and 3 will be null. 1 and 3 will be null because we have not defined the values. We have specifically mentioned the values for these indexes only, right? So these are some of the approaches by which you can assign some values to a column. I mean, it could be date, it could be state, it could be year, it could be pop, or your new column, your customized column. It could be anything. The approach will be same. Now say you want to create a new column, stern. So remember, this stern was never defined, but still we are able to call. So that's the beauty of Python again. So df2 stern equal to, I want to create a boolean array, boolean column, equal to, this is assignment, and this is comparison operator. So assignment equal to df2 dot state equal to ohio. So that means wherever states are ohio, uh, stern will be true, otherwise it will be false. So let's see. The stern column automatically generated because of this, because we have assigned. Okay, excellent actually, right? I mean, the beauty of Python. And stern got values assigned as true wherever the state is ohio. So state is ohio, yes, true. State is ohio, yes, then true. State is ohio, yes, true. And other than this ohio state, will be the other values will be false, right? This is a boolean column. Okay, so you got it. Now let's see how to delete a specific column. Okay, the command is del, df2 is the data frame name, and then you want to mention the column. So del df2 and then stern. So this column you want to delete it. Now let me put it df2 to print, I mean to see whether the data has been updated. Let's see. Okay, see stern column has been deleted. This column has been deleted. So I'll get state, year, pop, and date. State, year, pop, and date. Right. Okay. Suppose I want to create a data frame from the nested dictionary of dictionary. What is nested dict? Okay. Nested dict is like say, okay, so this is the dictionary value, right? Because it has key value pair. First, let's go from right to left. So this is a this is a key value. That key is 2001 and value is 2.4. Sorry, this one 2.4. Key is 2002 and value is 2.9. And this is a dictionary. So this entire dictionary is the value of this key of this dictionary, final dictionary. So this is again a dictionary. Remember, this is again a dictionary. This is one key value pair. Okay, this is another key value pair. And for this key, the value is again a dictionary. This is a dictionary, right? So this is a nested list of dictionaries, right? And for this value, again we have a dictionary value. So let's convert this to a data frame. df3, let's store it in df3 and let's build df3. So how it will go? Like say Nevada and Ohio are the two columns, and you know like 2001, 2000, 2001, 2002 will be the rows, and the values will be respective like 2.4, 1.7, 2.9, 3.9, null. Null why? Because here for Nevada there is no 2000 in index. We have not defined, right? If you check the Nevada column, we have not defined value for 2000. We have defined values for 2001 and 2002 only. That's why 2000 value has been null. Okay. And for Ohio, it is value are given. So for 2000 1.5, for 2000 1.7, 2001 1.7, and 2002 is 3.6. Okay. 2002 is 3.6. Right. Got it? Clear? You can write in chat box. Hope everything is clear so far. Please write it if it's clear. Okay. Good. Now, how to transpose a matrix? I mean, this is not a matrix. This is a data frame, but you know already how we transport a matrix or array, right? Earlier. So same way, like df3 dot capital T is the transpose. Transpose will be, so this columns will be now rows. I mean 2001, 2002, 2000, and then this Nevada row, Ohio row. Okay. So entirely transposed. Okay. Now say pd dot data frame pop. Okay. We are putting index equal to 2001, 2000, and 2003. Okay. So what it is going is going to create change the index numbers 2001, 2002, 2003. Okay. Got it? Okay. Now say df3 is this one. So df3 dot values, you know, will get all the values. df2 dot values will get the values of df2, right? Now say what we want to do is we want to create a series of 0 to 3, and we want to put index equal to 1, index equal to a b c. So how it will flow up? The values will be from 0 to 3, but the index will be a b c. If you print it, say a b c as the index, and value will be 0 1 2. 3 will be excluded because I said that Python does not consider the last value for these cases. Okay. And okay, so now what we are going to do is suppose index equal to obj dot index. Okay, obj dot index, you know that it stores the index. It shows the index value 0 abc. So if I store it in a different index column, what's the my index, and we are printing my index. So my index will be obviously abc, right? Because this obj dot index is abc. And if you want to access, like say my index 1 is 2, that means 0 1 so on till c. So it will print bc, right? Same thing, df3 dot columns, you can check the column names of the data frame. Okay, this is the data frame 2. Okay, suppose like dropping a column name, I can drop a row name also. Okay, how to drop a row entry? That time the function will be df2 dot drop, df, df2 dot drop, and then you need to mention the row index 5. So remember earlier my this is the data set. So if I see 5, this one was a value like Nevada 2001 2.9 minus 1.7. And if I'm dropping it, so the output will be 1 2 3 4 6, not 5, because 5 has been dropped. So let's print it. So 1 2 3 4, there is no 5 because 5 has been dropped, and 6. But remember, this function like df2 dot drop, it is not a permanent. I mean, it's not deleting the row from the original data set. It works like copy. It does not work like view. If it would have been view, then it would have been dropped, right? So df2 dot drop 5. This is just execution, but it does not remove the row from the original data. So let's print it, the original data. You will find 5 is still there. It has not been deleted. But if you use the delete column, then it will be deleted. Okay, like we removed a column, right? That time it deleted. Similarly, if we want to say drop 2 rows, okay, formula is same df2 dot drop, but I mentioned earlier also, when you have more than one parameter, that time you need to mention inside a list. So here we need to mention in a list because I have 5 and 6 also, both the entries I want to drop. So df2 dot drop, then 5 and 6. So now let's see. So 1 2 3 4 5 and 6 have been dropped. That's why 5 and 6 are not coming. But again, this is not deleting the rows from the original data set. If you still print df2, it will be retained. The originality will be retained. Okay. Now, if I want to say drop a specific column, that time we need to put axis equal to 1, because column means all the rows of the column I want to drop. That means axis equal to 1. All the rows means axis equal to 1, right? So dropping column entries, so df2 dot drop depth. So this time I'm not dropping the rows, I'm dropping a column, right? So depth and then axis equal to 1. So this will, if we print it, it won't show the depth column. So state here. And now if I want to say drop 2 columns together, Here it is not inside a list, but once we are going to drop more than one parameter, one column, that time we must write it inside a list, as I mentioned you repeatedly, right? So inside a list, pop and depth, and then x is equal to columns, or x is equal to 1 and x is equal to columns are same actually, okay? So df2 dot drop pop depth x is equal to 1 or x is equal to columns will drop these columns from the data set, but not permanently. This is for only for the output, right? So you have done so many operations, like you have dropped so many rows, you have dropped so many columns. Now, is the originality lost? Just to recheck. No, originality is not lost. Still, the data frame remains the same. Okay. Now, suppose I want to change the originality. I want to drop the columns or rows permanently. That time the command is df2 dot drop 5 in place equal to true. In place equal to true. This is the command which will remove this row permanently from this data set. In place equal to true means yes, I'm dropping the value from the original place. In place equal to true means drop the value from the original place itself. That's why in place equal to true. Now let's execute this. Okay, we are not viewing it now. Let's view this data. So 5 won't be there now. The originality is lost. Okay, with this command. So 1, 2, 3, 4, no more 5. You're printing the original data. Remember df2, but still 5 is not there. So 5 has been dropped permanently. Okay, and that you can do using in place equal to true. Now you know how to select a particular column. df2 pop will be giving the population column. Selecting two columns. I mentioned repeatedly that when you are selecting more than one column, you have to mention inside list. Okay, so df2 pop comma depth. So we are selecting two columns, depth and pop. Okay, suppose I want to select some row series. So selecting a row series, as you already know, list, arrays, etc. df2 is to 2 will give me like some 0, 1, not 2 because 2 will be excluded. So 0, 1. So 0, 1 means this is 0 row, this is 1 row. Okay, remember one thing. I don't know whether I have told or not. Maybe I have not. I might not have told. So basically, though the index remains this one, this like this 1, 2, because we have customized it, but originality is not lost. Okay. So if you want to access df0, still you can access it. So this will be 0 row, this will be 1 row, and so on. That's why if I'm using is to 2, it considers that 0 row and 1 row. Okay. So df2 is to 2 is 0 row and 1 row. Suppose it I used to say I use 4, so 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. So 1, 2, 3, 4. This will come. Okay. Now let me put some condition, and then based on the condition, we want to fetch the elements of the data set. So how to do that? So df2, then df2 of this population column greater than 1.7. What does it mean? Get elements from df2 and get elements for this df2 greater than 1.7. Okay, so population greater than 1.7. So let's see. Okay, this is not the original set. Original set is this one. This one. So 3.6, 2.4, and 3.2 should come, right? So there will be 3 rows coming. If you print it, 3 rows coming, because for those 3 rows, population column value is more than 1.7. 3.6, 2.4, 3.2, right? That's how you can access elements from dataset after putting some condition. Now, if you ask me, Avinash, what's the need? What's the importance of this? I'll I'll answer like this is very important. Suppose you have a 500 columns and say lakhs of or billions of records. That time it's very difficult or kind of impossible just to visualize the data from your eyesight by your eyesight, and then finding the values wherever it is greater than, say, suppose income is more than $50,000, or say income is more than $1 lakh, etc. it will be difficult. So using these scripts, you can automatically fetch those elements where the income is more than 50,000 or 1 lakh or 2 lakh or 3 lakh, etc. Right? Okay. So that's the importance to fetch some records based on your condition, based on your need, based on your business question, etc. Now, suppose I want to select the records for only for Ohio state. So how to code it? df2 df2 dot state and dot state or this one equal to Ohio. So this will fetch me all the records for Ohio, not for Nevada. So Ohio records were three records, one, two, three. Right. Similarly, suppose I want to select records only for the year 2002. So how to code it? df2 year equal to 2002. Okay. So this will be coming for 2002 year. 2002 year was so 2002 and 2002. So these three values. Ohio 2002, Nevada 2002, and respective Ohio 2002, Nevada 2002. So yeah, see Ohio 2002, those columns, those values, and Nevada 2002, those values. Okay. Now say we want to assign some values based on condition. So what's the condition? df2 lock. Okay, lock we need to use when we have non-integer columns and non-integer rows. Okay, so character columns or character rows. So df2 dot lock df2 update less than 0. Okay, this condition and comma depth equal to 0. So what I'm going to do is wherever depth column is less than 0, make it 0. Okay, it works like this. Wherever depth column is originally less than 0, make it 0. Let's see, and let's see. Okay, so basically it was less than 0 because it was minus, right? So 0, it has been replaced by 0. Okay. Now say we want to select those records where depth column is null. How to code it? df2 depth dot is null. Wherever is null, those values I want. So df2 depth and dot is null. So wherever null value, those records came. Okay. And suppose I want non-null columns from the depth column. So df2 dot depth dot not null. So that's the comment. If you see, all the not null values will be coming. Okay, got it. Suppose I did this operation, so what will be the new values of df2? df2, you know the values you have been already replaced. You have already replaced by 0. So depth column had been updated in the original matrix itself. So original matrix will be state, year, pop, depth, null, 0, 0, 0, these things, right? Okay, suppose I want to access the rows with index 2 and 4 only. So df2 dot log inside a list you need to mention 2 comma 4. So this will give you 2 row and 4 row. I mean, this 2 row means 2 index row and 4 index row, the name of the row. Okay, and now I would need only few minutes more. So now what is iloc? Iloc we can apply when we have integer um, integer uh, integer rows. I mean, when we want to mention the integer, that time we want to use iloc. So what is df2.iloc? df2.iloc in a list 1 and 3. So 1 means second row and 3 index means fourth row. So I want to fetch second row and fourth rows. And obviously you know second row is 2 and fourth row is 4. So it will work like this one only. df2.lock24 is same as df2.iloc 1 to 3. The difference being lock is used for non-integer values and character values, and iloc is used for integer indexes. That's the difference only. The output will be same. Got it? So if you want to use a df.iloc2, that means third row. 2 is index, third row. So third row. Third row value is state, year, pop def. These are the values for third row. Okay. If you want to access all the rows till 3, that time you need to use lock because we are putting character here. So is to 3 and lock function. So it will show you all the rows. So 1, 2 is to 3. Okay, like this. So remember, when you are using lock, that time index is returned. Okay, it does not. Earlier when we are putting like df2 is to 2, 2 was not included, right? But when you put lock, that means it will be locked, and this value will be also shown. That is the reason 3 is also being shown. But if we normally call is to 2, it will be giving you 0 rows and 1 column only, not the second one. But since you are locking it, it will give this column, this row also 3. Got it? Similarly, suppose I want to show all the rows, but only for the columns where year equal to 2000. So df2.ilog is to comma is to 3. I want to show the first 3 rows only, and where year equal to 2000. So df2.ilog is to, I mean, take all the values and then uh, columns till is to 3, right? Take, and wherever the year is 2000. So 1 and 4, those values have been year 2000, and these first 3 columns came state, year, and pop, not the date column, because we have put is to 3 columns, right? Now let's say we want to access the element at row uh, 2 and column pop. That time how we can define is df2.log. This is the row position and this is the column position. Here we are not defining inside a list. Do you know why? Because this is a, I mean, inside a list we are not defining because we want to call the respective row and respective column. So 2 is the row and pop is the column. So df2.log 2, this will come from row, this will come from column. So 2 and row, if you see 2 and pop column is 1.7 value. So 1.7, right? Similarly, 4 and pop, 4, where is 4? 4 and pop is 2.4. Okay. So if we want to access 4 and pop, so it is 2000, 2.4, right? So that's all for the day. Hope it was clear. Any question?